Hello, Algebra 2 students. This video will be reviewing Regent questions on Unit 3.5, Logarithms. Each section will contain a different standard on logarithms that the Regent could test you for. The first section is modeling exponential functions, and as we all know, logarithms are the inverse of exponential functions, right? We use logarithms to solve for an exponent. If $5,000 is put into a savings account that pays 3.5% interest compounded monthly, how much money to the nearest 10 cents would be in the account after 6 years? Assume no money was added or withdrawn. So compounded monthly, we know that's a finite amount, so we're going to use this formula. A equals P times 1 plus R over N to the N T. 5,000 is put into the savings account, so that's your principal value. The rate is, we want to see that percentage of interest as a rate, so we're going to move the decimal over to the left too. And it's compounded monthly, so we know that the N is 12. And now we have a formula. It says how much money to the nearest 10 cents would be in that account after 6 years. Oh, so we're not even using logs here. Excellent. So A equals 5,000, 1 plus 0.035 over 12 to the 12 times 6. Just plugging in 6 for t. And put that on my calculator. You get 6,166.505184. So approximately $6,166.50. Really, if we were using rounding laws, it would round to 51 cents. Okay. The loudness of sound is measured in units called decibels. These units are measured by first assigning an intensity I naught, or you could say I sub 0, just the initial I, to a very soft sound that is called the threshold sound. So I naught is the threshold sound. The sound to be measured is assigned an intensity I, and the decibel rating D of this sound is found using this formula. The threshold sound audible to the average person is that number right there. Consider the following sound classifications. How would a sound with intensity, whoops, meant to use blue, intensity, that number be classified? So we want to find how many decibels so that we could use this chart. So we're going to plug into that formula. So D equals 10 log, the intensity is 6.3 times 10 to the negative 3 over I naught, which is the threshold sound. So 1.0 times 10 to the negative 12. Make sure you're putting this in parentheses because it's the log of that ratio. Put that in your calculator. I would put, technically it's all multiplication and division, so you really don't need these. But you know, I always like to put the whole numerator in parentheses and the whole, no, you do need it. You don't need it in the numerator you need it in the denominator because technically, let's say you didn't include parentheses in the denominator, you would do this times this, which you want. You would divide it by 1, but you're not dividing it by this whole term. So just make sure, I always recommend, rule of thumb, just put parentheses around your entire numerator, parentheses around your entire denominator. Even if it might be unnecessary in some cases, you're not going to be wrong. Okay, I'm putting this on my calculator. Making sure everything's right. And you end up getting 97.99340549. 97 is in between 90 and 109, which is very loud. Okay? Now for graphing logarithms, there's really two things I could teach you. I could teach you how to do it in the calculator, which you're going to do. So we'll focus on that first. But if you don't have a calculator, I'll also teach you how to do it without a calculator. Okay. So, first with the calculator. I always recommend graphing your asymptote first. You know that with a logarithm, your argument cannot equal 0. Your argument is also going to be greater than 0, right? So, should I explain why? If you want to know why, I really do recommend looking at that overview video of logarithms, but the explanation is a log is just the inverse of a exponential, right? So let's do a basic exponential. Let's say y equals a times b to the x. Let's make it even more basic. So y equals b to the x. The inverse of that, you switch the x and the y, right? The inverse of that would just be y equals log base argument. Whoops. Okay? But you switch the x and the y. So this x is actually your y, and this y is actually your x. So that y is just the exponent, right? That x is the output. Can an exponent give you a negative? No, right? If we think about that, let's say we said 3 to the first power, 3 to the second power, 3 to the third power. That would be the same as saying 3, 9, 27. From left to right, you're multiplying by 3. But if you were to go right to left, you would be dividing by 3. So 3 to the 0 is just 3 over 3. Anything to the 0th power equals 1. 3 to the negative 1 would be 1 over 3. 3 to the negative second would be 1 over 3 squared, which is just 1 over 9. So your exponents could give you a fraction, your exponents could give you 1, or a number much bigger than itself, but it can never give you 0, and it's always going to be non-negative. So your argument must be greater than 0. Again, if you really want to understand this, this is just meant to be a review of what to do. The overview video of logarithms really goes deep into each concept. So, starting this question fresh. So if that felt confusing, you could ignore that. On the graph below, the graph of the function, log base 2 of x minus 3 plus 1. We want to find the asymptote. I always recommend finding the vertical asymptote first. So x minus 3 is greater than 0. You set your argument greater than 0. I'm going to add 3 on both sides. X is greater than 3. So if it's greater than 3, you could graph that line x equals 3. That's going to be the asymptote. And if it's greater than 3, your log is going to be on the right side of it. So now, what I recommend for you guys to do is to put it in your calculator and then just list out some points. So I go to y equals, go to math, go to log base 2 x minus 3 plus 1. And the points I'm seeing are 4, 1, 5, 2, 7, 3, 11, 4, 19, 5. And then you just have to graph those points. 4, 1, 5, 2, 7, 3, 11, 4. Is 19 on here? Let's see. Sixteen, 17. No, it's not. So, what I recommend doing, put a little arrow right there so you know that it doesn't actually reach 5 on this graph. So then you could connect the line. And then it could approach, but it could never touch that asymptote. So make it get infinitely close, but make sure you're not crossing that asymptote. That's it. You graph the function, right? Let me demonstrate. I'll demonstrate on 2 points how you would find these points without a calculator. So we'll do a little bit of extra work. But we did finish the question. This is it. So let's say we want to find where this equals 1. You set your log equal to 1. So your y is 1. And then you have to try to solve. So you're going to isolate the log. 1 minus 1 is 0. And then, you know, in order for a log to equal 0, that would be log base 2 of 2 to the 0, right? It's the base to whatever that number is. So, what we essentially just said is this has to equal 2 to the 0. So x minus 3 equals 2 to the 0. 2 to the 0 is the same as saying 1, right? Anything to the 0th power is 1. Add 3 to both sides. X equals 4. So you have an x, you have a y, that's a point. 4, 1. Look at that, we found 1 point. A lot of work to find 1 point, so I recommend using your calculator. Let's do one more. We want to find where it reaches 2. So log base 2 of x minus 3 plus 1 equals 2. This is where y equals 2. Subtract 1, you get log base 2 of x minus 3 equals 1. In order for this log base 2 to equal 1, your argument would have to equal 2 to the 1, right? So we just said that x minus 3 equals 2 to the 1. So that means x minus 3 equals 2 to the 1. 2 to the 1 is just 2. Add 3. You get x equals 5. Look at that. We have a y, we have a x. So you get the point 5, 2. Isn't that what we had from the calculator? As you can see, it's a lot less work if you are using your calculator. Something else to note. Not all calculators have log base. So what I did in my calculator, mine does have log base. I did second, math, scroll down to log base, and I just type in, right? You just type it in log base form. But if your calculator doesn't have that, you know log base argument is the same as saying log of your argument over log of your base. So in this case, rather than typing log base 2 of x minus 3 plus 1 into your calculator for y equals, you would type in log of your argument, so log of x minus 3, you'd click the log button, type in x minus 3, divided by log of your base, and then you would add 1 on the outside. So this is the same thing as this, and then you would get these points. Okay? But really, you just had to do this. It wasn't that much work. Okay. For this, we want to solve for t. So t is in your exponent, so you know if you're solving for an exponent, you're going to have to use log. So a e to the bt equals c. What you're going to do, isolate the base. You always have to isolate the base. So e to the bt equals c over a. Now you have to put into log base form, right? Log base, you could remember it as log bay, right? Log base argument or log base answer equals exponent. So what's your base here? E. So we have log base e of your argument, or if you memorize it as answer, just know it's the answer it's on the opposite side of the equal sign. So you have c over a equals your exponent bt. Now before we even solve for t, we know that log base e is just your natural log. You could type in log base e in your calculator if we were evaluating a number, like a finite solution or a defined solution. But log base e is the same as saying ln. So we have ln of c over a, it's just your natural log, equals bt. How do I solve for t? I want to get t by itself. So you divide by b. So that's either 1 over b ln of c over a, or it's ln of c over a over b. That's option 3. Okay. We're going to do basically the same exact thing we just did, but it's a lot less abstract. It's actually the exact same. It's base e as well, so we could use ln. So you isolate the base. So we have log base e of your argument, right? It's on the opposite side of the equal sign, equals your exponent, 0.3x. If you want to convert it to ln, you can. You don't have to. You could type in log base e in your calculator. You know to type e, it's second divide, but it's easier to click the button ln. And then to solve for x, you just divide by 0.3. So in my calculator, I'm typing, and this is on every calculator. You click ln, 5,918 divided by 87 divided by 0.3. You end up getting x equals 14.066152238, option 4. Okay. Which expression is not a solution to the equation? So this kind of plays on your logarithm laws. Something you could easily do. Let's say you really are not getting this. You could convert to log base form. Log b, right? Log base argument equals exponent. So to convert that, right? Log base argument or answer, it's whatever's on the opposite side of the equal sign, That's a 2, by the way. Equals exponent. So it's saying which one's not a solution, so we know to cross out 2. If you have this step, you could just type the rest into your calculator, and you'll get some long irrational number probably. But you'll see that all of them equal one number, except for one of them. But I'm going to show the logarithm laws, because there's really not much to teach from that everybody should be able to do. So we know x to the m over n equals the nth root of x to the m. So when you have a square root, that's essentially saying the second root, right? So that's the same as saying x 10 to the 1/2. So we have log base 2 of 10 to the 1/2, right? Square root is just the 1/2 power. And then we know our power law for logs. If you have a power or an exponent in your log, you could separate by multiplication, bring it to the front. So we get 1/2 log base 2 of 10 equals t. So we could cross out number 1. And now, for this one, I'm going to rewrite this down here. Log base 2 of radical 10 equals t. Now, we know that a log, they have to have proportionate exponents from the base to the argument. So how do I get from 2 to 4 using exponents? 2 squared. So I could square the base and square the argument, which is just log base 4 of 10. And we know that would be equivalent. So your answer would have to be 4. That's the only one that's not a solution. Again, if that's too much to know, all you have to do is convert to log base form and then just plug everything into your calculator and see which one's not equivalent. Actually, even if you didn't know log base form, you could type in just these, and then one of them would be a different solution, right? But I do recommend, understanding what you're doing. But for the sake of passing the Regent, obviously, do what you need to do. Judith puts 5,000 into an investment account with interest compounded continuously. Okay, compounded continuously. Immediately you should be thinking per, right? A equals P times E to the RT. That's when there is a continuous or an infinite compounding. Which approximate annual rate is needed for the account to grow to 9,110 after 30 years? Probably not even going to use logs here because they give you the time. Oh, no. Yeah, you are. You're looking for the rate. So she puts in 5,000 times E to the R. We don't know R. 30 years. I could have wrote 30R, but I'm plugging into the formula as you could see. We want to know when it reaches $9,110. First step, always isolate the base. So now you have E to the 30R equals 9,110 over 5,000. Convert to log base form. Your base is E. Your argument is what's on the opposite side of the equal sign. Your exponent is 30R. We know that log base E is just ln. And you're going to divide by 30 to solve for R. So now I just have to click the ln button. ln of 9,110 divided by 5,000, close parenthesis, divide by 30. You end up getting that R equals 0.0199978266. Be careful. This is a rate. we want the percent. So, in order to get a percent from a rate, you move the decimal to the right 2. And you would get 1.999788266, which is approximately 2%. Okay? All right, last question. One of the medical uses of I-131, a radioactive isotope of iodine, is to enhance X-ray images. The half-life of I-131 is approximately 8.02 days. Patient is injected with 20 milligrams of I-131. Determine to the nearest day the amount of time needed before the amount of I-131 in the patient's body is approximately 7 milligrams. So exponential decay, that's this formula. 1 minus r to the t. Not unfortunately. T is days, right? And it's going to well, I want to discuss this a little differently, actually. Okay. So, a half-life. We know that it's going to be halving. So the rate of decay would be 1/2. Your base would just be 1/2. So this is going to be 1/2. Your principal value, which is in the patient, is 20 milligrams. Okay? And we're talking about the amount in the patient. Now, let me leave the formula like this for a second. Let's think about what that means. That means there's 20 milligrams of I-131 in the patient. And T is a day, right? So imagine you plugged in 1, meaning 1 day. Does it have after 1 day? It doesn't have after 1 day. It has after 8.02 days, right? So, what we just learned, right? We want this, when this equals 1, to have. So we're going to have to offset it a little bit. So, what I mean is that when the exponent equals 1, we want it to have. And that's after 8.02 days. So what could you do to 8.02 to make it 1? You could divide 8.02 by 8.02. And then that's your formula. Right? Does that make sense? Because without what I wrote in red, right? If you plugged in 1 for 1 day, it's not supposed to have after 1 day. It's supposed to have after 8.02 days. So when you plug in 8.02, we want that to 1 out in the exponent. We want it to equal 1. So 8.02 divided by 8.02 would be 1. Hopefully that makes sense. So it says determine to the nearest day the amount of time before the amount of I-131 in the patient's body is approximately 7 milligrams. So 7 milligrams equals 20 times 1/2 to the t over 8.02. Isolate the base. Convert to log base form. So the base is 1/2, or you could put 0.5. The argument is what's on the opposite side of the equal sign. 7 over 20 equals the exponent. Let's solve for t. So you could multiply by 8.02 on both sides. Put that in your calculator. So I'm going to do math, log base. I could have typed 8.02 first. But 1/2, 7 divided by 20, and I'll multiply by 8.02. T equals 12.14687685. Says to the nearest day, so approximately 12 days. Okay. I hope that helped. Less tip though, just for those of you that don't have log base in your calculator, the way you would type that into your calculator, type 8.02 times log of your argument divided by log of your base. Right? And then that would be the same thing. Okay, thank you.